All right, so we are looking at dividing square roots. We did multiplying yesterday. We also looked at I. We're going to see I show up again today. We're going to continue working with that. But we're going to use I as we're also going through with division. All right, so you know how in math there's usually like goofy rules that you're not really sure why they're there, but they kind of have to be? There's a goofy rule with dividing. But in other words, the first thing we need to talk about, though, if you have a giant radical that like covers an entire fraction, I know you guys don't like fractions, but don't panic because we can split that radical, one on top and one on bottom, and then we can just treat them separately. So me personally, the first thing I always do is I split that radical apart. Okay? So if I split it, I have radical 3 over radical 4. Square root of 3 I can't really do anything with. I can't make a factor tree on, but the square root of 4 is just 2. Okay, so first thing is we can split those and we can deal with them separately instead of as a fraction. All right, so let's go ahead and practice some of those. So number one, first thing, let's split it apart. We'll do them separately. Things on my board move. There we go. All right, so I would split that to radical 16 over radical 49. All right, write that separate. And then we can just treat them like two separate problems. So the square root of 16 is 4. Square root of 49. Does 4 over 7 simplify? So we're good. Done. It's nice when they're pretty and perfect, right? All right, what about number 2? Let's split. Yeah, I was trying to get your process going. I know some of you can do that in your head. But we'll go ahead and split it first. Right? That way we know we can treat these as two separate problems. Square root of 2, can I do anything there? No? Donnie, you all right, hon? You look so tired. You look so tired today. And the square root of 81 is 9. And we're done. Right, I can't actually take the square root of 2, so I can't just say it's 2, because that's not right. Yeah, so that radical is going to stay. Yeah, you'll have answers with radicals in them all the time. Yeah. Is there still a radical on it? You're not going to reuse toilet paper, are you? See, I knew there would be at least someone's going to do it. Okay, so good question. Why am I leaving the radicals versus why am I not? Square root of 16 is 4, not radical 4. Right, I used the radical to make 16 a 4. Here, I can't use the radical on the 2 to change it to anything, so it has to stay there. I can't use it. Yeah, so if you use it, throw it away. Flush it, right? Don't keep it around. All right, so number 3, again, we'll split it first. So radical 8 over radical 25. And then we can treat these separately. Square root of 8, is that perfect? But can I do a factor tree on it? Yeah. Right, so if you can do your factor trees, remember, I'm treating these like two separate problems, right? I'm just doing them separately. I didn't do a factor tree here because 2 is just 2 times 1, so that doesn't mean it doesn't do much for me. But I do have a pair of 2's, and then I have a single 2. So I'm using the radical on the 8 to change it into 2 radical 2. Did my factor tree, took my couple out, I'll leave my singles inside. And then on the bottom, the square root of 25, that's just 5. Do I keep the radical on it? No, because I used it to make it a 5, so it's done. How are we feeling so far? Not bad? It's like I got a problem on top and a problem on bottom, right? No, I turned the 8 into 2 radical 2. Just like we were simplifying before, I'm still using that simplifying method. Don't you love math? It just keeps building, right? What we learned yesterday and the day before is still coming up today. Oh, sorry. I just simplified radical 8 like we have been doing, where I did my factor tree and looked for pairs. Yeah, so I just did the factor tree on the 8, had a pair of 2's, so that came out, and then my singles stay in. So it's just like simplifying a regular one. Just now we have a fraction, so I have to do top and bottom separately. I've created 2 problems instead of 1. All right, ready for the goofy rule in math? There's always those goofy rules. All right, so someone, somewhere, a long time ago, and I honestly can't even tell you why, they say that is not simplified if there is a radical in the denominator. We cannot leave them there. So on this example, right, radical 4/3, we'd split, so radical 4 over radical 3. We've made it two separate problems. The square root of 4, I can tell you, is 2. So I used the radical, so it's gone. On the bottom, radical 3, I can't do a factor tree on that. I can't simplify it, so it'd still be down there. But there's a radical on the bottom we're not allowed to have. Okay, so we have to get rid of that radical. So to eliminate the square root, you have to rationalize the denominator. So if you hear me say rationalize, is what I'm talking about. It's trying to get rid of that radical. So continuing for this problem down here, to get rid of it, whatever this radical is, that is the same number that you will multiply top and bottom by. If you multiply by the same number on top and bottom, what does that really equal? If I have a 5 over 5, that's just 1. Does it change anything if I multiply by 1? No. So it'll look different, but it's not going to actually change the value of it. So whatever that radical is in the bottom, no matter what it is, you are going to multiply top and bottom by it to get rid of it. And what happens, radical 3 times radical 3 is radical 9, and the square root of 9 is 3. See how there's no longer a radical in the bottom? Then on the top, 2 times radical 3, that number's outside, that number's inside, so they don't actually multiply, right? They just kind of sit next to each other, and that stays there. But the goal is to not have a radical in the bottom. It's considered not simplified. All right, and that seems a little crazy, but it's really not bad. Once you get the hang of it, it's a piece of cake. But one thing it drives me crazy. So if I have radical 5 times radical 5, what does that equal? Radical 25, which is 5. Okay, so if I have radical 10 times radical 10, what's that? Which is, if I have radical 3 times radical 3, that gives me, which is, anybody noticing a pattern by now? So if I have radical million times radical a million, what's that equal? It's million. Radical Jonas times radical Jonas is Jonas. So if you multiply the same radical together, it always is going to equal that number without the radical. Are we seeing that? I'm trying to help you guys out because I'm that lazy mathematician. I don't want to write this and then take it to this every time. If you have to, that's fine. But I'm just trying to get you to see that pattern that shows up. Jonas? Mm-hmm. Right. If it's in the denominator, then I'd rationalize doing what we were just doing here. You would leave it radical 10. Yeah, because it doesn't, there's no pairs. All right, let's go ahead and get some practice with this. So number 4, 7 over radical 5. So there's no like giant radical to split, so I don't have to do that. All right, can I simplify the top? Can I do anything with the bottom, factor tree, anything like that? No. But can I leave a radical in the bottom? No, so I have to rationalize it, which means you multiply top and bottom. Got to be fair, right? Got to be fair if I do it at the top and the bottom both. So on the top, what is 7 times radical 5? 7 radical 5. And on the bottom, radical 5 times radical 5 is radical 25, which is just 5. Can you answer? So where did Abby go? All right. Does that look good? You guys okay? Understanding? Right. We can have radicals on top, totally fine. Cannot have them on the bottom. Now, I'm going to tell you right now, as we get going, the problems do get a little harder, obviously. They're going to kind of build a bit. I have students who try to rationalize the denominator from the start. Your problems get big, ugly, and really hard when you do that first. Okay, so let's kind of break this down, maybe some steps to follow. I know that helps a lot of people out. All right, so steps to follow here. So the first thing you're going to want to do is split your radical. So in other words, if you got one of those big, huge radicals, you're going to want to make that a radical over a radical. Right? You're going to want to split that. That was the first thing that we did today. So that'd be the first thing that I would always do. Right? The next thing I would try to do is to simplify all radicals. Okay, so like we were doing before, if I have a radical on top and I have one on the bottom, I've now created two separate problems. I'm going to try to do my factor trees. I'm going to try to simplify them. So simplify all radicals. If it helps you, write factor trees. All right, after I've done that, next I would rationalize my denominator. Yes, yes, it did. Sorry, my one time part's cut off, so I was waiting to see if it was moving. Thank you, though, for checking. All right, so rationalize denominator. That's where we're multiplying top and bottom by whatever that radical is. And then your last step is to simplify again, if you can. So simplify again, if possible. Sometimes it happens, sometimes it doesn't. But what happens is people will flip-flop steps 2 and 3. And you can do the problems if you flip-flop steps 2 and 3, but your problems get ugly. And I mean ugly. So I'm trying to help you keep things a little smaller and a little more manageable. So simplify your radicals first, then rationalize if you have to, and then see if you can simplify again. Izzy? The imaginary? Somebody else earlier today said invisible. That's funny. Imaginary. They do. That would come from step 2, simplifying my radicals. I'd pull out the I. Yep, absolutely. Yes, if that was on top. Yep, absolutely. And we'll look at some of those in a little bit. All right, so number 5. Let's kind of go through my steps. Do I need to split the radical apart? No, I don't have a big giant one. Step 2, simplify the radicals. Yeah, if I look at radical 6, if I do a factor tree, I get 3 and 2, which there's no pairs, so nothing comes out of that. All right, next is rationalize my denominator. So I have to multiply top and bottom by radical 6. Make sure you're fair. Top and bottom get the same. So what is 6 times radical 6? Good. 6 radical 6. Radical 6 times radical 6 on the bottom, which is radical 36, which is just 6. Okay? That was step 3. I rationalized my denominator. And then step 4, simplify again if possible. Does anything simplify? The 6 is. Now, this one's under a radical. I can't touch him, but this 6 and this 6, those cancel out. So it's just radical 6. Yep. But you see how I want you to follow those steps. And I'll look at one in a little bit where I'll flip-flop steps 2 and 3 so you can see the difference. You can do it, but they get ugly. All right, number 6. Do I need to split my radical? No, it's already split apart for you. Step 2, simplify all radicals. So can I do a factor tree on 10? I mean, I could, and I would get 2 and 5, so no pairs, nothing. Factor tree on radical 3? No. All right, so I don't do that step. Rationalize denominator? Yep, so we're going to multiply top and bottom by radical 3, because it's the bottom that cannot have a radical. Top's fine, bottom cannot. So on the top, what is radical 30? It's radical 30, thanks. So on the top, it gives me radical 30. On the bottom, radical 3 times radical 3, radical 9, which is just 3. All right, so that was step 3, rationalizing your denominator. And then can you simplify anything else? Good, I can't divide because one's under a radical and one's not, so I can't, those don't work together. Can I do a factor tree on 30? Do you get any pairs? It'd be 3 and 10, and then 2 and 5, so there's no pairs. All right, so that was as far as that one goes. All right, so I'm baby stepping you, as I always do. We're baby stepping. So if we hit a point where you're like, whoa, please ask, okay? All right, what about number 7? Go through your steps. Split the radical? Don't have to. Step 2, can I simplify any of those radicals? Radical 2, 15 would be 3 and 5, no pairs, so I can't do anything there. All right, so then rationalize. So you multiply top and bottom by radical 15. So 5 radical 2 times radical 15 is what? 5 radical 30 over 15. Because again, this will give you radical 225, which is then just 15. Okay, and then last step is simplify again if you can. Can I simplify that again? What? Good, it would be 1 over 3. Because if we're looking at this, now this is underneath the radical. I can't really do anything with that. All right, that doesn't simplify with these. That doesn't give me a factor tree that does anything. But 5 and 15 can both be divided by 5. I can divide them both by 5. So that's going to give me 1 radical 30 over 3. Do I need the 1? No, I don't need the 1. But for those of you that are like, where did it go? It's a 1. Yeah, sure. All right, so what about number 8? What do I do? Good, I got to split. All right, there's that step came in. So let's split your radical. So radical 5 over radical 14. So that was step 1. Step 2, can you simplify any of those radicals? Thinking about factor trees. Yeah, factor tree on 5, nothing happens. 14 would be 7 and 2, no pairs. Okay, so I can't do anything there. Step 3, rationalize. Yeah. So we multiply top and bottom by radical 14. Radical 70 over 14. And then simplify if you can. Radical 70, factor tree there. There's no pairs. Yeah, if you try, it's going to give you 7 and 10, which is 2 and 5. There's no pairs, so nothing happens to it. So Jonas, does that answer your question? You asked me about the radical 10 earlier. All right, number 9 is where people start to fall apart on me. Yeah, and most don't. All right, so again, let's go through our steps. Step 1 is to do what? Split them apart. So radical 27 over radical 8. What's step 2? Simplify. And a lot of students are like, I'm going to go to step 3. Like they just totally bypass step 2. Yeah, it makes it way harder. Yeah, your numbers get bigger and it's, ugh, yeah. So step 2 says to simplify your radicals. So I can do a factor tree on 27. 9 and 3, 3 and 3. Perfect. Got a pair of 3s which come out. A single 3 stays in. Okay, so I simplified my top radical. Can I do anything with the bottom radical? Another factor tree for that one. Good, so I have a pair of 2s that come out, and a single 2 stays in. I am. All right, so from here, Donnie? Yeah. All right, so from here, right, we followed our steps. We did step 1, we split it. Step 2 was simplifying each of the radicals. In this case, they both simplified. Step 3 is rationalize. What do I multiply top and bottom by? Just radical 2, right? Because that's the only part that's bothersome, right? I can't leave the radical in the bottom. That's the bad part. So we multiply top and bottom by radical 2. Now I'm going to take you kind of step by step through this one so I don't lose anybody. All right, so on the top, what's 3 radical 3 times radical 2? 3 radical 6. On the bottom. Okay, I'm going to write it down step by step. So it would be 2 radical 4. But what's radical 4? Times this 2, that'd be 4. So 3 radical 6 over 4. And then simplifying again, 3 over 4 doesn't simplify, and I'm done. Okay, so when you're rationalizing the denominator, and there's like an outside number, that's fine. But you're only going to multiply top and bottom by whatever that radical is, not the number out here as well. Okay? How are we feeling? They're fun. I like them too. She's like, are you crazy? These are not fun. Real quick, I want to show you, so radical, hold on. I want to show you what I see a lot of students do. All right. So it was radical 27 over radical 8, right? I want to show you. You can still do it, but how much harder your life gets. You don't have to write this down, just kind of pay attention. So I have students who will flip-flop steps 2 and 3. They will rationalize as soon as they see there's a radical in the bottom, which is a bad idea. They will multiply right away radical 8 on both of them. 27 times 8, 216. That'd be radical 64, right? Your numbers got huge. So then I have to simplify my radicals. So I'm going to have to do a big factor tree on this. 2 and 113. Let you find. So it'd be 3 and 12 and 18. 12 and 8. Wait, oh. You started as 12 and 18. I'll start there. My brain hurts on this Friday to do much mental math. 12 and 18. All right, so 4 and 3. 2 and 2. 6 and 3. 2 and 3. Do you see already how much more work this is? Okay, so then they're like, all right, so I got a pair of 3s. I got a pair of 2s. I have a single, give me 6. So that's 6 radical 6. On the bottom, radical 64 is 8. And then your last step is to simplify again. These can both be divided by 2. So that would be 3 radical 6 over 4. Did I get the same answer? Yeah. How much more work was it? Your numbers get a lot bigger and you have more simplifying to do, which to me causes more times to not do it, and then you get things wrong. Okay, so if you simplify your radicals first and then rationalize, your numbers stay a lot smaller and easier to work with. Yeah. All right, so number 10. Step 1. Split. Hey, we're going in order here, guys. First step is split. So I'm going to rewrite that. It would be radical negative 63 over radical 52. All right, step 1 is to split. Good, and right away she's like, there's an I, and she's right. There is. Yeah, you're fine. So really I have I radical 63 over radical 52. All right, so yeah, if you got that negative under the radical, pull out the I. All right, what's your next step? Simplify your radical. Think about if you tried to rationalize this. You would have 63 times 52. Your numbers are getting huge. Let's not do that. All right, so we'll do a factor tree on the 63. What do you multiply to get 63? 9 and 7. 3 and 3. Good. So we get a pair of 3s. We still have our I. And then you have a single 7. All right, so we simplify the top. Okay, 13 and 4 on the bottom. 2. Good, so pair of 2s. Single 13. Between the two of you. All right, questions so far? We split it apart, and then we just simplify both of our radicals. No, question? Yeah, they're just hanging out. Yep. All right, and then from there, your next step, what's step 3? Nope, that was step 4. Step 3. Did you write the steps down? Step 3 is to rationalize. So step 3 would be to rationalize. So I need to multiply top and bottom by radical 13. Notice I did not multiply by the 2. 2 is not in a radical. He's fine. I just need to get rid of that radical. So on the top, what is 3i times radical 7 times radical 13? 3i radical 91. So on the bottom, that's going to give you 2 radical 169, but the square root of 169 is 13 times 2 gives me 26. And then the last step is simplify anything else if you can. 3 over 26, nothing goes into that. Radical 91, if you do a factor tree there, the only things that multiplied to give me 91, where'd that come from? 7 and 13, and those are both prime. So that is as far as that one goes. If you have questions, make sure you ask, okay? If I hear silence, I assume we're good, and I'm just going to keep going. Good? Okay. All right, number 11. Step 1, split it. Is it already split? It's already split. I don't have to do that. So step 2 is to simplify your radicals. Take the I out. Now, what is this? It's like a negative 1 sitting there. So really, it's like I have a negative 1I, radical 36. What? All right, number 11. All right, so we pulled out the I. Well, where do we go from there? All right, so simplify my radicals. Square root of 36. So what do I have on the top? Negative 6I. Good. I can simplify the 48. Factor tree there. Okay, 8 and 6. 4 and 2. 2 and 2. 3 and 2. Good. Pair of 2s is 4. Single 3. Okay, hold on a sec. Let's make sure we're all on the same page. All right, questions to there? All right, so next step is to rationalize. So we have to multiply top and bottom by what? Radical 3. So on the top, so again, make sure we're clear on the bottom. That would give you 4 radical 9. But square root of 9 is just 3 times 4. Gives me 12. And then the last step is to simplify again if you can. Anything simplify again? I could divide these both by 6. So divide them both by 6. So negative 1I radical 3 over 2. And again, you wouldn't need the 1 there, but if you have it, that's great. Dividing it by negative 6? If you technically, I guess you could, but it would put the negative on the bottom of your fraction. No, you're fine. You mean divide? No, you're fine. I just want to make sure I'm understanding your question. Yeah, 6 is the biggest number that goes into both. And the reason I didn't do negative, because that would make a positive 1 on top, but then 12 divided by negative 6 would leave a negative 2. So I still have a negative somewhere. So usually by default, depending on your calculator too, some calculators don't like a negative in the denominator. If you type it in, it gives you an error. So by default, I always just leave my negative on the top. So it doesn't matter. If you went with a negative on the bottom, it's not wrong. How are we doing? Jenna's first day back, she's like, I want out of here. All right, you guys want to try this one on your own? No? Okay. Well, let's talk about the first part together, and then I'll let you finish it on your own. What's the first thing you would do with this? You'd pull the i's out, right? So if you have I radical 40 over I radical 6, what's happening to your i's? They're going to cancel out. Okay, just so you know, those will cancel out. So why don't you guys go ahead and finish from there. Let me give you a couple minutes. All right, guys, let's go ahead and finish up this last problem. So we went ahead and pulled out our i's. I on top, I on bottom. That's where those cancel. So you don't have to worry about them. So our next step then is to simplify any of these radicals. So I can do a factor tree here. All right, so from here, we have a pair of 2's that come out. I have singles, so it's going to give me 10. Now on the bottom, if I do a factor tree here, I get 2 and 3, but there's no pairs. The question came up from someone else. How do I know whether to do a factor tree or not to? You always try, okay? But the thing is, if I do a factor tree, there's no pairs to come outside, so they have to stay inside together. Okay? All right, next step is to rationalize. So we'll multiply top and bottom by radical 6. So I'll get 2 radical 60. Radical 6 times radical 6 is radical 36, which is just 6. Can I do a factor tree on the 60? So 6 and 10, 2 and 3, 2 and 5. So then I find a pair of 2's, and I have a singles, give me 15. And then 2 and 6 can both be divided by 2. So I get 1 radical. Oh, wait, I lost something. Ha, I did. Somebody else did that earlier, and I caught you on it. Yeah, I probably did. Yeah, we had a pair of 2's that came out, times this 2 gives me 4. There it is, sorry. See, I make mistakes too, it's okay. So then we get 2 radical 15 over 3. And again, are there different ways to attack these problems? There are. There absolutely are. All right, but overall, how are we feeling? Do we understand we have the 4 steps, right? And that's okay. Take your time. Take your time. The biggest thing, guys, is before you circle that final answer and call yourself done, some things should run through your mind. One, double check your radicals. Can you do a factor tree on any of those and find some pairs? Okay, and then also check your outside numbers. Can you divide them both by something to simplify them? All right, nothing kills me more than when people circle this as their final answer. I'm like, did you even look at the 4 and 6 that you can divide them by 2? Okay, so always be looking for that. Other questions on anything? No, I thought we'd do the homework over, like, derivatives. Is that okay?